Next we will see how to simulate this executable file using Proteus Design Suite 8. So you need to open this Proteus Simulator. So this is the icon for that. You can click on that. So Proteus Simulator will be opened. Here first step is you need to create a project. So you can click on this new project. Click on this new project. So project wizard will be coming. Here it will be asking for the name of the project. You can give the name as a LED blink project. Then this will be the path of storing the project, right? Then automatically it is selected as new project. Give next. So here it will be asking for create a schematic. So first you are going to draw a circuit diagram and you are going to simulate. So you by default it is selected create a schematic. By default it is default. Then give next. Here it is asking for whether you want to create a firmware project. That means whether you are going to write a program in Proteus. So you should give no firmware because I have written the program in Keel. So by default it is no firmware. Don't do anything here. Give next. So here it is showing that only schematic is added. Firmware is not there. Give finish. So project workspace will be opened. So this is known as a workspace. In the left hand side you can see the toolbar and this is known as the device list. Whatever device you are going to add in the project will be shown here. Now no devices are there. So as the first step we are going to add few devices. First one will be LPC microcontroller. So in Proteus you are not having 2148. You are having only 2138. There is no problem in that. Only few differences are between 2148 and 38. So instead of using 48 you can very well use 2138. So for taking the components you need to click on this toolbar, this op-amp symbol, that is known as component mode. Whenever you want to add a component you need to click on this component mode, right? You have selected component mode, then you need to click on this P, that is pick from libraries, right? First you need to click on component mode, then click on this P, pick from libraries. Here in the keyword section you need to give LPC2138, LPC2138. So it will be shown here LPC2138, right? Then double click on this. When you are double clicking on the result you can see that in the device list LPC2138 is added, right? Controller you have added. Next device you need to add is a LED. So for taking LED you can give LED hyphen yellow. For time being I am taking yellow LED. So LED hyphen yellow. So you'll get yellow LED active animated LED model, right? So you double click on this also. So that also is added. Then let us take for time being we are only using these two. For the simulation purpose you don't need that resistance. So for time being you are adding these two only. Then you need to close this window. This is a pick devices window. You click on OK. So now two devices are added here. Next what you are going to do, you are going to draw the circuit diagram. So first you are going to draw the circuit diagram. So first you are going to add the controller. So first click on this controller. Then you need to take it to this workspace. This is workspace. So no need of dragging the controller. You simply click on the controller. Don't drag. Move the cursor to the workspace. No need of dragging. Move the cursor to workspace. Click once. When you are clicking once, you will be getting a skeleton so that you can keep it wherever you need. When you are clicking once, you will be getting a skeleton. Click once more. So your controller will be fixed here. Controller is fixed. Now you are not able to read the whatever pins it is written here. So you can zoom it by clicking on the zoom in icon. So let us take you are clicking 2 times. So when you are clicking, when you are zooming more, you can see that some of the portion has gone outside the viewable area. This is a viewable area. So how will you make it visible? For that, on the left hand side you can see one green box here on the left hand side. Click on that once. So when you are clicking on that once, that mouse has been changed to this plus symbol. So wherever you are keeping that green area, so that green area means your visible area. You keep it wherever you need. So for time being, I am keeping it here. So once you are keeping the green box wherever you need, click once more. So when you are clicking, you can see that plus symbol has been changed to the arrow and viewable area is fixed now. Right. So now the first step for writing the program is that you are going to connect the VCC to the controller, VCC and ground. Right. So these are the VCC pins. These are the ground pins. All the VCC and all the ground pins should be connected to where here in ARM controllers your VCC is 3.3 volt. Right. You need to give 3.3 volt. Don't give 5 volt. So for that, for taking the supply, you need to click on this generator mode. In the toolbar, you need to click on this icon generator mode. So you will get all the generators, all the waveform generators you will get. From that, you need to click on DC generator. Click on DC generator. Again, no need of dragging. Click here once. So you'll get the generator. Then what you need to do? You need to make the connection. How will you make the connection? You can click on the starting point. So when you are clicking on the starting point, you will be getting a red square. Click there once. Click there once. Again, don't drag. Then move your cursor to the ending point. Again, you will get a red square. Click there once more. So these two are connected. Similarly, you connect all these things to this VCC itself. So you are connecting like this. I have made all the connection. So I have taken a DC source. I have made the connection to all the VCC pins. Then you need to configure this VCC as 3.3. How will you do that? You need to double click on this DC generator. Double click on this. Then you will get here. You can configure here what voltage you need to give. You give it as 3.3. You can give it as 3.3 volt. You are specifying the voltage as 3.3. Give OK. So now I have configured the DC source to generate 3.3 volt. Then all these pins should be connected to ground. So for taking ground, you can click on this terminals mode. Can you see this? Terminals mode. Click on this. All the terminals you will get. From that you click on ground. Click on ground. Don't drag and keep it here. Similarly, I have told in the previous time, you connect all these pins to this ground. No need of dragging. Click at the starting point. Click on the ending point. So I have made all the connections to ground, all the connections to VCC. So VCC I have configured. I have connected. Next step is I need to make the connection with the LED. So how will you take that LED? Now you are in terminals mode. You need to go back to components mode. So again click on component mode. Click on component mode, then only you can see that. And LED should be connected to port 1 pins. Which are the port 1 pins? P1.16 to P1.31. You can see here. For time being, I am connecting only one LED. So in one pin, so click on LED yellow. Click here, right? Then one end of the LED, you need to connect it to, say, you are connecting to P1.16, make the connection. The other end you need to connect it to ground. How will you take the ground? You need to again click on terminals mode, take ground, keep it here, make the connection. Similarly, I can connect one LED here also, or here also I can connect one more LED. Click on component mode, take the LED, make the connection here. Then I am connecting it straight itself. This also you can connect it to the ground. So one LED I have connected to P1.16, another I have connected to P1.22. In my program, I can connect LEDs from P1.16 to 31. All the 16 LEDs will be working. So I have connected like this. Then, so I have my circuit is ready. My VCC and ground is ready. Next step is you need to configure the clock frequency for this controller. So for that, double click on this controller. Double click on this controller. Here you need to specify the crystal frequency as 12. Crystal frequency you need to specify it as 12 megahertz. You can see it as clock frequency is 12 megahertz. Then in the next step you need to program the hex file what you have created. So that should be shown in the program file. What hex file you need to run here. So click on this browse button. Go to your folder. I have created it in D drive. LPC2148 underscore course. Inside this LED blink project.hex file. This hex file should be loaded there as program file. Give open. So LPC2148 course LED project LED blink project.hex. So this is an executable file. This is a clock frequency. Don't do anything else. Give OK. Right. So now I have configured the program. I have configured the clock frequency, crystal frequency. I have configured the VCC. I have connected the LED. Then the next step is you need to start the simulation. For that, on the left hand side bottom you can see an icon that is known as run the simulation. Click on that. So when you are clicking, you can see that your LED will be blinking. LED starts blinking in whatever rate you have configured. If you want to keep an resistance here, you can keep a resistance 100 ohm resistance here also. So the brightness of the LED will be slightly reduced. Right. So if you want to keep the resistance here, you can keep that, no problem. For time being, I am not keeping it here. Right. This is how you are simulating a small LED blinking program using LPC 2148. Here 2148 is not there, only 2138 is there, using Proteus Simulator.